Hi everyone, welcome to my talk. Before we get started, let me introduce myself first. I'm Dunith Dhanushka, a developer advocate from StarTree. At StarTree, I work very closely with Apache Pinot, which is an open source real-time OLAP database, which you can use for real-time analytics. And then I'm interested in any technology that is related to event-driven architecture, event streaming, and real-time analytics as well. And every once in a while, I blog about that in my Medium publication. And you can also find me on Twitter as well. All right, let's get started. Now let's look at what are three different types of analytics you can find in modern organizations. First, we have descriptive analytics, or we call it historical analytics, which tells you about what happened in the past or why did it happen. For example, you can analyze past sales records and figure out why there's a sudden drop in the sales in past month. And then we have real-time analytics, which tells you about what's happening in your organization or business right now. For example, you can analyze the incoming orders and figure out what's the total value of orders, what's the total sales as of now. Or you can even calculate the average order value during the last 5 seconds. And then finally, we have predictive analytics, which tells you about what's going to happen in the future. So this is where we usually bring in machine learning and AI to build machine learning models and train them based on the historical data so that the model can predict the future based on past behavior. For example, we can feed this model historical sales information and have it predict the sales for the next quarter. So in this talk, I'll focus on real-time analytics, and I'll show you how Solace PubSub Plus and Apache Pinot and Apache Kafka can be worked together to build a real-time analytics system. What exactly is a real-time analytics? It is a process of collecting, processing, and analyzing business data in real time to derive actionable insights. Real-time analytics is different from batch analytics, or we call it offline analytics. It is where we usually collect data in batches and analyze them in a periodic manner. So you will get analytics in a delayed manner. So that's the one shortcoming of this batch analytics. But compared to that, real-time analytics is fast. That's where you can see, you can access your analytics and insights in the moment you collect your input data. So that you can make faster business decision to make it for a competitive advantage. In order to cater to that, your real-time analytics system must be fast, accurate, and scalable to support billions of data points at a time. Also, we can observe a close relationship between event-driven architecture and real-time analytics system. Typically, event-driven architecture promotes event-first thinking, enabling you to model state changes in operational systems as discrete events. For example, if we consider withdrawal against a bank account, we can consider this particular withdrawal as a discrete event. So this event can have a unique event ID, also a timestamp where this withdrawal event happened, also some payload information along capturing some metadata information like the account ID, what's the location of the branch, the bank account, ATM details, and so on. Also, event-driven architecture provides necessary infrastructure to capture these business events and move them to consumers in a reliable and scalable manner. And this is where event brokers like Solace PubSub Plus is coming to the scene. Usually in a event-driven architecture, event broker decouples these event producers and event consumers so that they can produce and consume events in a asynchronous and loosely coupled manner. And in that note, real-time analytics systems can also be considered as a consumer of the event-driven architecture. So an analytics system can be configured to connect to event broker and consume events, and then derive or generate analytics as new events lands in. And next we'll see how Solace, Kafka, and Pinot work together to build a real-time analytics infrastructure. So here we have like three technologies. In the left-hand side, we have Solace as the event broker, and it takes care of event collection, interfering with event producers and routing, etc. And in the right-hand side, we have Apache Pinot, which is our analytics engine. So Pinot is, it can ingest event from Solace and have it available for querying. To bridge these two worlds, we have Apache Kafka and Kafka Connect in the middle. As you already know, Solace PubSub Plus platform excels at event streaming, and particularly for managing events in transactional and operational use cases. Also, it supports a wide range of real-time communication protocols, including MQTT for IoT devices, and also to cover a vast majority of web and mobile application. It supports WebSockets and other protocols, messaging protocols like TCP, JMS, and so on. Also, PubSub Plus is ideal for implementing the publisher subscribe pattern at scale. So it comes with rich features like hierarchical topic filtering, dynamic routing, and so on. And then we have Apache Pinot. Pinot is a real-time distributed OLAP database. Pinot can answer complex OLAP queries on large data sets with millisecond range latency. So what do you exactly mean by OLAP queries? So we have OLTP queries and OLAP queries. So basically, OLAP query returns a large number of records after applying operations like aggregations, filtering, and sorting on large number of records. So that's the difference. Typically, these OLAP queries are complex to execute, but in context of Pinot, it can execute these queries with millisecond range latency. Also, Pinot can maintain this latency SLAs even at a higher query throughput. That means if you have like billions of users concurrently accessing Pinot, it can serve each one's queries with the millisecond range latency. Also, Pinot brings in built-in indexing strategies to make querying and retrieval faster. Also, its internal representation is columnar format. When it comes to indexing, it has these inverted indexes, range indexes, and also geospatial indexes, JSON indexes, and text indexes for a couple of targeted use cases, searching and real-time use cases. Apache Pinot, so these kind of use cases makes Pinot ideal for building real-time applications and systems. Say, for example, Pinot is good at building user-facing analytics systems. Building user-facing analytics dashboard is challenging because we need to provide a better user experience. That means we need to be able to provide OLAP queries at the speed of OLTP systems. Pinot excels at doing that. Also, Pinot can be used to build internal BI dashboards, data products and data APIs, and also recommendation systems and anomaly detection systems, and so on. To bridge these two worlds, we have Apache Kafka. So if you have Kafka deployed in either in cloud or in your on-premise data center, this will be an ideal use case. So basically, Kafka comes with its ecosystem component called Kafka Connect, which allows you to move data in and out of Kafka from external systems. So for example, if you want to read from a database, JDBC database, or something external system like Elasticsearch, you don't have to code it from the hand. So all you have to do is you have to find the necessary Kafka Connect connector and deploy it to Kafka Connect and configure it accordingly. Then data will start flowing from these systems to Kafka. Also, Pinot can be configured to ingest or consume data from Kafka topic in real time. All right, now let's see how we put together all these technologies together. So there are a couple of ways we can do that, and we can treat this as a reference architecture for building a data analytics infrastructure with Solace. All right, so everything starts from left side in the Solace. So in Solace, you have queue or topic that receiving events from event producers. So Solace is the primary interface where you interface with event producers all across the world. So it can be internet or internal network or anywhere. And then we have to somehow bring in this data to Pinot. So that's where we bring in Apache Kafka and Kafka Connect. So we have Apache Kafka, this special connector called Solace Kafka Source Connector, which you can deploy on Kafka Connect, and then you can configure it to listen to that particular queue or topic in Solace PubSub Plus, and then route these incoming events to a topic in Kafka. And then you can also configure Apache Pinot to ingest data from this Kafka topic and make them available for querying after few seconds. So the best thing is whenever an event lands in Solace, it will be immediately available in Pinot, allowing you to query that in a matter of seconds. And then Pinot can be accessed and queried by various analytics consuming systems, like including human users and applications. When it comes to human users, there can be data analysts running dashboards and building dashboards and doing ad hoc querying. Also, there can be data scientists doing experimentations on these kind of data sources. Also, there can be other systems like applications like data-driven applications, user-facing dashboards, always accessing data on demand from Pinot. All right, now let's see everything in action. So for better understanding, I have put together a small demo about building an e-commerce analytics system on these technologies. Now let's have a look into that. Let's assume we are building a real-time e-commerce order analytics system. Let's say e-commerce orders are streaming into a topic in Solace PubSub Plus platform. So they are produced by web and mobile application. And then we have Solace Kafka source connector deployed in Kafka Connect, and it is configured to listen to this topic in Solace PubSub platform and route incoming orders to a topic in Kafka. Let's say the topic name is orders. So whenever a new order comes into Solace, it will be immediately show up in the orders Kafka topic. And then we need to do some sort of a real-time processing on these incoming orders. For example, we need to see what is the current total sales value and what is the current count of orders coming in. For that, we need to have Apache Pinot in the picture. So Apache Pinot can be configured to ingest orders from the orders Kafka topic, and whenever new orders comes in, it will be made available in Apache Pinot for query. And then finally, we can have analytics consuming applications and other users like data analysts to query Apache Pinot with ultra low latency, and while the data is still fresh. So that's about our end-to-end data analytics use case. When it comes to the implementation, I have already provisioned a PubSub Plus cluster in this Solace console, as you can see here. When you go to Cluster Manager, you can see my EDA Summit cluster is already up and running. It has been provisioned in the AWS Cloud, and currently it's running. And you can see some related cluster credentials here as well. Right. And then rest of the stuff I have deployed in my local machine using Docker Compose. So as you can see here, this is my project structure. So I have config folder to keep my Kafka Connect and other Apache Pinot configurations here. And then I have a connectors folder, which I use to put this PubSub Plus connector here. And then I have a couple of data and other related folders. In the root folder, you can see my Docker Compose file. So here, as you can see, in Docker desktop, you can see a couple of Docker services are already up and running. Several application clusters in the same Docker Compose project. Here we have single node Zookeeper cluster, Kafka and Kafka Connect clusters, as well as Pinot cluster with 3 containers. Here we have Zookeeper, so it's defined here. You know, Apache Pinot and Kafka are distributed systems, so they depend on Zookeeper for critical tasks like centralized metadata management and cluster coordination. And then here we have Kafka exposed on the standard 9092 port. And then we have Kafka Connect. Here we have 2 volume mounts, and the first mount is pointing to /opt connectors directory of this image, and it is referring from the local connectors folder, as you can see here. So this is where I kept my PubSub Plus Kafka source connector. Here I'm not going to go deep into explain you how to install and configure this source connector with Kafka Connect, because you can already find that information from Solace website. So at a high level, what I have done here is I downloaded this connector from Solace website, and which is free of charge, and then extracted it and moved into this folder. And then I open up this etc Solace source properties file and did a couple of configuration changes. So the first configuration I did is to mention the destination Kafka topic where this connector should route the orders coming from Solace. So it's the orders topic that I have already configured here. And then the rest of the these parameters specify my PubSub Plus broker cluster properties. In fact, you can find this information from your Solace console. If you click on this Connect tab, and if you use this Connect with Java option, you can find Solace Java API, because from within the Solace connector, source connector, it uses this Java API to connect to Solace and get results. And once you click on the connect service, you can also find all this username, password, and these other information. So this information might get changed or different from your cluster settings. And then finally, I have this sol.topics to specify the source topic where this connector should read incoming orders. Also, I have another volume mount, which is actually pointing to the Kafka Connect standalone properties file, which you can find inside Connect standalone. Here I have made two configuration changes. First, I am setting the Bootstrap server to my already running Kafka instance, a Kafka container. Also, I have already uncommented this plugin path and change it to point to the OPT connectors volume path, so that it can easily pick up the Solace Kafka source connector. And the rest of the services are related to Pinot. So we have Pinot controller, broker, and server. Typically, you need 4 components to properly function a Pinot cluster. First, you need Zookeeper, which is already there. And then we need a Pinot controller. So basically, Pinot controller is the brain of a Pinot cluster. So it acts as the central administrative interface of a Pinot cluster, which receives for incoming administrative commands and executes it to make changes to cluster status. And then we have Pinot broker, which takes care of query execution. So it can receive SQL queries on consumers like data-driven applications and dashboards and other users. And then once received, these queries are scattered among multiple Pinot servers. And so once servers finish query execution, the broker gathers their responses back, compiles into one single output, and responds back to respective clients. And then finally, we have Pinot server, which actually hosts the incoming data. So whenever Pinot receives data, it converts this data into segments and writes into the disk. Basically, a segment is a file in a columnar format. So Pinot comes with different indexing strategies. So these segments can be applied with multiple indexing. So then it will make searching and retrieving of data inside these segments faster. All right, that's about our Docker Compose project. And let's go to Pinot Query Console. So this is a web application that comes with Pinot controller. So basically, this provides administrative interface to an already running Pinot cluster. So in the home page, landing page, you can see the cluster health, overall cluster health, the number of controllers, brokers, and servers. So you can see this metadata here. And then we have Query Console, which allows you to query tables in Pinot in interactive fashion. So basically, a table in Pinot is something similar to a relational database table. Pinot table is composed of multiple segments. Also, a Pinot table is associated with a schema. Basically, schema describes the look of a table. Schema, if you click on this orders table, you can see the associated schema. So yeah, for the time being, I have already defined this orders table and the order schema for this demo. Once you click on this relevant table, you will see its schema and other information. Also, this built-in SQL editor allows you to type in any queries and run these queries against this table. For example, right now, I don't have any data in this topic, Kafka topic, so in this table as well. So that's why you see a blank output. All right, let's see. Let's try to publish some data and see whether we can see any change here. This is an example e-commerce order record formatted in JSON that I'm going to publish to Solace. So if you look closely, you can see each and every record should have order ID, customer ID, region, amount, and timestamp in this single record. So if you go back to Pinot and check the order schema, you will see the exact field names are present in the order schema. So when JSON objects received by Pinot, it can automatically pass this JSON object and save it to orders table. All right. So now let me copy this sample order object and go back to my Solace Cloud here. Here what I'm going to do is I'm going to simulate a mobile application publishing a couple of e-commerce orders into my Solace PubSub plus topic. So for that I'm going to use the try me feature. Here I'm going to use this publisher. So basically it is publishing a couple of events over WebSockets. First I'm going to connect it, and then I should mention the source topic as order source because I have already configured this name in my source connector properties file, if you remember. And then I can paste my JSON object here and set the payload to text and try publishing. All right, it says one message has been published, Apache Pinot, and see. Run the query again. All right, now I see this record has already been published. Let me try another record as well. Go back. Write 2 messages and let's get back to Pinot and see whether it can see. All right, it is already there with order ID 2. Let me publish another few records as well. All right, altogether I have now published 5 messages. That means 5 orders. And if you go back to Pinot, you should see exactly 5 orders here. Yes. So that's the beauty of it. See the time between the publishing of records and time of querying is less than it's in few seconds. So that means data is still fresh and Pinot can answer your queries very faster. Now let's try to run a query against this data. So for example, I need to find out the total number of orders and the total number of total sales as of now. So for that I run this query. So you can see total number of orders is 5 and total sales is like this number. So that's it.